Running a Hollywood studio or mapping a global supply chain used to require hundreds of specialized human silos. In March 2026, Sakana's AI scientist autonomously generated hypotheses, ran experiments, wrote complete manuscripts, and passed blind peer review for a Nature publication. The entire research lifecycle cost $15. Meanwhile, Google's AlphaEvolve is autonomously analyzing and rewriting complex data center scheduling algorithms, recovering stranded server resources without a single human keystroke. The historical barriers of time, funding, and scale that governed knowledge production for a century are gone. The immediate reaction to these systems is the assumption that they will replace human knowledge workers entirely. But look closer at how they are actually deployed. The emerging model is the sovereign individual, a single human acting as director, commanding an autonomous AI co-architect. To command this architecture requires a new set of operating instructions, strict, unyielding rules to build and pilot this human-machine symbiosis. These instructions allow one operator to execute the computational workload that once defined entire departments and multi-million-dollar budgets. Step 1 is to establish the directorial bedrock. Autonomous power scales poorly without rigid human intent guiding it. In Clarisse Curie's Maison Aesthetic Studio OS, this is codified as the Class 1 immutable bedrock, a non-negotiable foundation of system governance. The operator must hard-code a negative prompting matrix. These are absolute red lines designed to block the system from generating useless or degraded outputs. Curie's system explicitly bans static slideshows, video loop padding, and degraded stock audio. If an operator fails to enforce these unyielding architectural rules, the system immediately regresses to generic, uninspired averages. The machine only delivers high-density output when the human operator enforces uncompromising boundaries. Step 2 is to define and measure, drawing directly from the AlphaEvolve protocol. You do not tell the AI how to solve a problem. You provide a baseline seed algorithm and a ruthless scoring metric. Bounded by constraints, the system systematically explores a vast search space, churning through iterations to find the optimal path. Enterprises use this metric-driven exploration, feeding the system operational constraints to optimize global supply chains and demand forecasting beyond human capacity. The modern operator creates value entirely by defining the exact parameters of success. The iterative execution belongs strictly to the machine. Step 3 is the reflexive loop. The Inago report on autonomous scientific research outlines why this step is critical. Blind reviews show AI-generated ideas rate significantly higher for novelty, but they are incredibly fragile in execution. Left unchecked, they produce hallucinated citations, fabricated data, and physical impossibilities. To counter this, operators establish a closed bidirectional feedback loop. The AI serves as generator, while the human acts as the unforgiving validator. The human must independently cross-check numerical outputs, prove physical ground truth, and validate logical consistency before final approval. The system acts as an autonomous engine of discovery, but rigorous human verification prevents a total structural collapse. When these 3 steps are executed in perfect alignment, the outputs scale dramatically. Clarisse Curie's Studio OS transforms a raw text screenplay into a 4-track 4K master in exactly 7 seconds. In industrial logistics, FM Logistics applied similar autonomous routing optimization and saved over 15,000 kilometers in staff warehouse travel. This protocol compresses months of traditional department labor into a sequence of verified human-machine iterations. Work in the post-2026 economy centers on orchestration rather than the manual generation of raw assets. The manual labor of generating art, writing code from scratch, and crunching raw data is functionally obsolete. Humans now occupy the role of the cognitive orchestrator. They exist to strategize, design verification protocols, and serve as ethical gatekeepers. You can adapt to this manual and command the machine, or cling to the old silos and fade away. Commanding these systems transfers institutional power back to the individual artist and researcher.